We will start with reading what we know from the graph. Vs is equal 15 volt. It is the source voltage. R, the resistance, is equal 10 kilo ohms, and that means that this is 10 times 10 to the power 3 ohms, and that is equal 10 to the power 4 ohms. C, capacitance, is equal 10 micro F, and that is equal 10 times 10 to the power 6 F, which is 10 to the power minus 5 F. We are looking for V. See the voltage across the capacitor. We are also be writing it as V. First step would be putting what we know to those two equations and make them equal. So we know that Vs minus V over R is equal T dV over D. We will multiply both sides by R. Vs minus V is equal RC dV over dt. R is 10 to the power 4 times t, which is 10 to the power minus 5. dv over dt is equal Vs, which is 15, minus V. Simplifying the powers of 10, we end up with 10 to the power minus 1, which is 0.1 dv over dt. That is equal 15 minus V. First part of our task is solved. My first step will be multiplying both sides of the equation by 10. So I have dv over dt is equal 10 times 15 minus v. Now I will multiply both sides by dt. So dv is 10, 15 minus v dt. And I'm dividing both sides now by 15 minus v. Therefore, dv over 15 minus v is equal 10 dt. I have everything that has v in it on one side, everything that has t in it on the other side. Now I'm taking integral of both sides. Left side is equal minus natural logarithm 15 minus v. If you are uncertain about this solution, you can solve it using the method substitution, and that is equal 10t plus c. Now I'm multiplying both sides by minus 1, so natural logarithm 15 minus v is equal minus 10 minus c. Instead of minus c, I can write as plus c1 because it's just a constant. I will take exponent of both sides, so 15 minus v will be equal e to the power minus 10t plus c1. Using laws of indices, 15 minus v is equal e to the power minus 10t times e to the power c1, which is yet another constant. 15 minus v is equal constant k times e to the power minus 10t. Therefore, v is equal 15 minus k e to the power minus 10. From our question, we also know initial condition stating that at point t equals 0, the value of v is equal 0. So we will use that to find the value of k. v is equal 15 minus k e minus 10 times 0. This is when we put t 0, and the value of v is then equal 0. Therefore, 0 is equal 15 minus k. E to the power minus 10 times 0 is 0. E to the power 0 is simply equal 1. So we have 0 is equal 15 minus k. Therefore, k is equal 15. And our solution now has form v of t is equal 15 minus 15e to the power minus 10t. And that is equal 15, 1 minus e to the power minus 10t. Our next task is sketch the graph of the function, and then we will be calculating what percentage of initial source voltage is gained at each following stages, t equals 0.1, 0.2, and 0.3. we will start with sketching. So to do that, we need to remember that the function a times e to the power minus kt has shape that looks like that. So it's going to 0, never reaches it, the function is decreasing. And of course, this is with the assumption that a and k are larger than 0. If we want to sketch minus a e to the power minus kt, so the function e to the power minus kt is multiplied by negative, we have to reflect our function with respect to the x-axis, so this will be the shape. We are adding positive constant. That means that we are shifting our function alongside y-axis. The shift is in the direction to the top. Our function will look more like that. And the asymptote, instead of being at position 0, will be at position 15. Where the function starts, will it be point 0, 0? Let's see. At point 0, the value is 0. We know that from our initial condition, but we can also calculate that by putting value t inside the function. So this is actually the starting point. We will try to calculate what percentage of the initial source voltage is gained at each of the following stages, t.01, 0.2, and 0.3. To do that, we need to put values 0.1, 0.2, and 0.3 into our function. T 0.1 is equal 15, 1 minus e to the power minus 10 times 0.1, which is equal 9.38. Approximately V of 0.2 is equal 15, 1 minus e minus 10 times 0.2, which is 12.97, and V of 0.3 is equal 15, 1 minus e minus 10 times 0.3, which is approximately 14.25. Now, we are asked what percentage of the initial source voltage it is. For t equals 0.1, it's 9 for 48 divided by 15 times 100%, and that is 63%. For t equals 0.2, we have 12.97 divided by 15 times 100%, and that is equal 86.5, and finally 1425 over 15 times 100% is equal 95%, and this is for t being equal 0.3.